So in this session, we'll do the questions related to topic rate, redox, and reversible reactions. In the first part, propene nitrile is manufactured from propene as shown in the following equation. You can see the reversible reaction as well. And the forward reaction, because there's a negative sign, it means the forward reaction is exothermic. The process is carried out at a temperature of 450 and around 2.5 atm. In the presence of suitable catalyst, state and explain effect on the position of equilibrium when each of the following changes is made to the reaction condition. The temperature is increased. So we have to state and explain effect on position of equilibrium because the forward reaction is exothermic, and for exothermic reaction, if we increase temperature, as we know the reactants have high energy and the product is having low energy. So when we increase the temperature, means more energy is supplied, so reactant absorb energy and they will form a product. So what will be the effect of increasing temperature? This will shift the equilibrium towards the left hand side. So equilibrium shifted towards left. And what is the reason for that? Because the forward reaction is exothermic. Because the forward reaction is exothermic, that's why that is the main reason that equilibrium is shifted towards the left hand side. The next question, the pressure has increased. So if we increase the pressure, increase in pressure shift the equilibrium towards side where number of moles of gas are less. So when we check the number of the moles of gas, so here 1, 2 and 1.5, so the total number of the moles of a gas, that is 3.5. And here it is 1 and 3, so total number of gas 4. So if we increase the pressure where the equilibrium will shift, it will again shift towards left hand side. So increase in pressure shift the equilibrium towards the left hand side. And what is the reason? Because few moles of the gas present on the left hand side. That's why this causes the shifting of equilibrium towards the left hand side. The third part, chemical manufacturers also uses a reaction condition to control the rate of chemical reaction. The curve in D2 and D3 shows the distribution of the molecular energy at a temperature T. Label the axes on the diagram in D2 and D3. So we have to label these axes for part D2 and D3. So what are the labels we use for these? On x-axis, because it is about the energy, and on y-axis it is about, and you can mention energy, or on y-axis you can mention the number of the particles or the fraction of the molecule or the proportion of the molecule. So here we will have, on y-axis we will have number of the molecules, and on x-axis we can mention kinetic energy or only energy is acceptable. On the figure, on the diagram below, draw a curve to show the distribution of molecular energy at higher temperature. So what will happen at higher temperature? And use your diagram with a further label as necessary. Explain why the rate of chemical reaction has increased. So what is the reason? What will be the another label? We'll add another label, that is activation energy. So the particles which are after activation energy, they are actually reacting and forming a product. When we increase the temperature, what will happen? Greater number of the particles will have higher energy. So the peak is shifted towards the right hand side and the height of this peak will decrease as well. Area will not change because area under the graph shows the number of the particle. That's why the area won't change. Area will remain same. The only thing what happened that when we draw this curve, so initially the peak which is there is it will be lower and it will shift it towards the right hand side. And then as we already label EA activation energy, so what is the reason why the particles, you can write this as activation energy. So this is activation energy. So you can see greater proportion of the particles at a higher temperature or T2, there is a greater area. Greater area means greater proportion of the particle have energy more than activation energy. That is why the rate of the reaction will increase. Is it clear? You can draw in this manner as well. Like instead, as I change drastically here, then you can show a this gradual change. For the number of the molecules. So peak slightly shifted towards the right hand side, but the area under the graph will increase. The particle which have energy more than activation energy will be more. Is it clear? This part? So you have to use a space there to explain the idea. Then the next part, use the diagram with a further labeling as necessary. Explain why the rate of a chemical reaction increases when the catalyst is added. So when we add a catalyst, the shape of the graph won't change. The only thing what happened, like if this was the activation energy without catalyst, so this will be the activation energy with the catalyst. So with catalyst, it will be larger, means more particles will be there after activation energy, and that is the reason why. And when the labels which we add here, the same label like proportion of the molecules or number of molecules on the y-axis and energy on x-axis. So you can see with the catalyst there will be greater proportion of the molecule. Without catalyst, few molecules are there. The same thing you have to write in the spaces available. So you have to use this to explain the idea. This question is about some aspects of chemistry of iodine and its compound. In industry, main source of iodine is sodium iodate, NaIO3, which occur in a deposit found in shell. In human body, iodide ion are there. Is there in chili, and the thyroid glands to function properly. Potassium iodide is there added to a table salt as a source of iodide ion. In the production of iodine, the final stage involves a reaction between sodium iodate and sodium iodide in acidic condition, acidic solution. The ionic half equation for a redox process are shown. Use these half equation, deduce the full. So how we deduce the full equation? Number one, to balance the redox equation, the half equation, to first we balance oxygen by adding water. So that is already done. You can see there are 3 oxygen, so 3 water molecules are added. The second thing, we to balance hydrogen, we add proton. That is also done. Then we balance the charge. Here -1 is there because this is one molecule, -1 and -5, so total is -6. And this one is plus, so total -5 and -1, so total is -6, and this protons are there which is +6, so overall it is neutral on the right and the left hand side. So the first equation is already balanced. We don't have to balance the first equation as it is already balanced. Now we have to balance the second equation. So how we can balance the second equation? Because when two equations are there, we have, and we want the final equation. So the second equation is already balanced as well in terms of charge, in terms of iodine number. But what we have to do to write a combined equation, we should have same number of electrons. But if one substance is losing electron, the other should gain the same number. In this one, 5 electrons it is gaining, but this one is losing, iodide ion is losing only one. So it is not balanced. So first what we have to do, we have to multiply the second equation by 5. So the first equation won't change, it will remain as it is. That is iodide ion plus 6 protons plus 5 electrons, half iodine molecules plus 3 water molecule. And then when we multiply this by 5, so 5 iodide ion, this will be 5 by 2 because we multiplied by 5, so iodine molecule, and this will be 5 electron. Then what we do to write a combined equation, we add the two equations. When we add, the electron will cancel with electron. So here we have 5 electrons, so this cancel. When we solve, so it will be IO3 with a charge -1. Then there are 6 protons. Then 5 iodide ions are there. Then iodine molecule, when we are adding, so like it is 2.5 plus half. So it is 2.5 plus half, it is 3 iodine molecule. So this will be 3I2 plus 3H2O. So this is a balance equation, a combined equation for a reaction between iodide 5 and iodide ion. Is it clear, this part, that how we write the balance equation? The next part, identify by its formula the oxidizing agent. So which one is an oxidizing agent? Because the substance which help in oxidation, by itself it is reduced. So when we identify here, as you can see in this iodate ion, this IO3 is there. The whole molecule is, it's a molecular ion, whole is having a charge of -1. So what is the charge of individual? Each oxygen is -2. So this is for each. At the below I'm writing for each. So 3 oxygen -6 will be there. So iodine should be +5 so that the net charge will be -1. So in the reactant side for first equation, iodine is having oxidation number of +5. But on the right hand side, because iodine molecule is there, like half iodine molecule, so in a molecular state, the oxidation number is 0. So what is happening? First for iodine, it is +5, and this +5 change to 0. So if we have +5 and +5 change to 0, so it means the oxidation number decreases, or we call that as reduction. And for substance which reduction happens, that is an oxidizing agent, which help in, by itself it is reduced, but help in oxidation. So which substance is oxidizing agent here? And we have to tell in terms of electron, because the substance oxidizing agent having the same definition as reduction, which is a gain of electron. So you can mention IO3 ion, you can mention like this IO3, or the original compound. Basically this was formed when we were having sodium iodate 5. The sodium iodate 5 decompose into sodium ion and iodate ion, and this iodate ion is reacting with iodide ion. So it is acceptable that if you write IO3 iodate 5 ion, or you write sodium iodate, both are refers to oxidizing agent. And what is the reason why they're oxidizing agent? Because they're reduced, or reduction happen. And why reduction happen? Because it gain electron. So whenever a substance gain electron, it reduce, or we call that as oxidizing agent or oxidant. On addition of concentrated sulfuric acid to the crystals of potassium iodide, solid sulfur and a black solid is observed. So a black solid was observed among the product. Identify the black solid. So what will be the black solid here? As sulfur is better or a good reducing agent, here as a result iodine molecule is for iodine is turned into iodine molecule. So when iodine turned into iodine molecule, so this black solid is basically the iodine molecule. So that is iodine. Then construct ionic half equation for formation of sulfur from sulfuric acid. Now we have to construct this equation and they give you the reactant and product. So sulfuric acid is there. What is the formula for sulfuric acid? Sulfuric acid is H2SO4. And as a result, what it forms sulfur. Now, as we already discussed, that if we want to write a balance equation, what we do, if we want to balance oxygen, we add water molecule. So on the left hand side, I have 4 oxygen. So how many water molecule I should add? So I will add 4 water molecules. So 4 H2O I added on the right hand side. Now, as we balance oxygen, hydrogen, when we check, there are 2 hydrogen on the left and there are 8 hydrogen on the right. So how many protons? Because to balance hydrogen in a redox equation, we should add proton. I will not add 8 protons because 2 are already there. 2 hydrogen are already there. So as a result, how many protons I will add? I will add only 6 proton. So this equation is now balanced in terms of hydrogen, oxygen and sulfur. Then we have to balance the charge. How to balance the charge? So this is plus 6 on the left hand side and neutral on the right hand side because sulfur atom is there, water molecule. So to make it neutral on the left hand side, we add electron. So how many electrons I should add? So I should add 6 electrons because overall, because each electron is -1, so 6 electron will be -6. So on the left hand side and the right hand side, the equation is balanced. So this is the balance equation for formation of sulfur when sulfuric acid react with iodine, and as a result it will form sulfur. Is it clear how we construct the equation by only the reactant and the product given? The redox equation. Any doubt in this part or anyone want me to repeat? When iodine react with concentrated, another product is there. This part is actually related to the group reaction, so we will discuss in that. The gas is actually hydrogen sulfide is there, but you will not understand right now as we did not discuss this specific reaction. In the next chapter, this reaction in detail we will discuss. Then recommended dietary allowed RDA for iodine in the balanced diet should be 140 microgram per day. That's the intake of iodine. Calculate the mass in microgram for potassium iodide needed to supply RDA of iodine, and your answer should include 3 significant figure. So basically, if we have 1 molecule of potassium iodide, it will provide 1 potassium ion and iodine. So we can take the ratio of the mass, the total mass of potassium iodide So we have the formula moles equal mass in gram over molar mass. As I mentioned here, 1 microgram this is what we need every day. 140 microgram. And we have to calculate the mass in microgram of potassium iodide that is needed to supply the iodine. So 1 iodine is basically provided by 1 potassium iodide. So we can work out the moles first. As we know, the ratio is 1:1. So first we'll find the moles of iodine, and using the moles we'll work out the moles of potassium iodide, and at the last we'll multiply by molar mass. So we will get the mass in gram. So moles equal mass in grams. So we are getting the moles of iodide ion. That is the mass per day. What we need 140 micrograms. So 140 into 10 to the power minus 6 divided by the molar mass, like relative atomic mass or molecular mass. So here it is 126.9. When we divide, we'll get the moles of iodide ion. So moles of iodide ion, 140 divided by 127 or 126.9. So this will give us 1.1 into 10 to the power minus 6. So these are the moles of iodide. And what is the ratio between iodide ion and potassium iodide? The ratio is 1:1. So if we have 1.1 into 10 to the power minus 6 moles of iodide ion, we'll have same number of moles of potassium iodide. After getting the moles, what we do, because we need a mass in grams, so we'll multiply by molar mass. So 1.1 into 10 to the power minus 6 multiply by molar mass of potassium iodide. So what is the molar mass of potassium iodide? It's 126, or you can say 127, and 127 plus the potassium mass is there 39. So this will be 126.6, 126.9 plus 39. So this will give you the mass in gram, which is about 183 into 10 to the power minus 6 grams. So this is the amount of potassium iodide which we should intake every day to get this amount of iodide in our diet. Is it clear, this question? That how we work out the mass of potassium iodide needed in the diet so that we can have a balanced diet and iodine intake. Suggest a reason other than the cost why some countries do not add potassium iodide to table salt. So what could be a reason why some countries are not adding this? So it can have many reasons, like maybe the other food stuff are having that iodine, so they are not adding. Or if when we are adding potassium iodide in the table salt, it means it is also providing potassium ion, and potassium ion is harmful. So that can cause increase in the blood pressure. That's why some countries are not adding potassium iodide in the table salt. When chlorine is passed over iodine crystals, iodine monochloride is formed. Iodine monochloride is a liquid at room temperature where chlorine is a gas. Explain in terms of intermolecular forces why this is so. So this is related to intermolecular forces. So we can mention in intermolecular force, because both are simple molecular structures. ICl is also a simple molecular. As you can see, ICl, there will be a sharing of electrons, so it is a simple molecular. And Cl2 is also a simple molecular. So when both of them are simple molecular structure, here, because of difference in the electronegativity, chlorine is more electronegative, so partial negative and positive. Whereas chlorine molecule, in a chlorine molecule, it is Cl2. So Cl2 both have the same tendency, so it does not have permanent dipole or dipole-dipole force. It will have dipole-induced dipole force or London dispersion force. So here we can mention the major force will be permanent dipole. Whereas in chlorine molecule, because two atoms are sharing electron, they will have dipole induced dipole force. When molecules have the same electronegativity, the shared pair of electron is not shifted towards any side, so which leads to dipole induced dipole force. And why in ICl the intermolecular force is stronger? What is the reason? Because this is ICl, there's another molecule, so negative, and so there will be attraction between the poles. So you can mention intermolecular forces or force between the ICl molecules will be stronger. Or even whenever you have electrons, you can also mention like this will have permanent dipole and dipole induced dipole. Dipole induced dipole is always there, but as the number of electron increases, the dipole induced dipole force will also increase. So there are two types of forces, permanent dipole and dipole induced dipole. Whereas chlorine, it is only dipole induced dipole. And dipole induced dipole force or London dispersion force increases as the number of electrons increase. If we have more electrons, we'll have a stronger dipole induced dipole force. So you can mention that in ICl there are more electrons, that's why the London forces or dipole induced dipole forces are stronger, which leads to a higher boiling point, or higher melting point, or we can also say that we need more energy to overcome the intermolecular forces. So it is important that way you compare the two substances. When excess of chlorine is passed over iodine, iodine trichloride is formed. Draw a dot and cross diagram for ICl. 3 show only the outer shell electrons. So iodine trichloride is there. We have 1 iodine and we have 3 chlorine. Remember, as the number of the electrons, like as the number of the shell increases, then the octet rule, as we discussed in IGCSE, that the first 20 elements try to complete octet. But that is not valid for all the elements, because as the number of the shell increase, the atoms can adjust more than 8 electrons in the outermost shell. So as a result, when you are drawing ICl3, what will the structure? Iodine, even though it belongs to group 7, so if it belongs to group 7, it should share 1 electron. Chlorine also belongs to group 7, so it should also share 1 electron. But this won't be a case here. Why this won't be a case? For example, if chlorine shared 1, iodine will share 1. If chlorine shared 1, iodine share 1. Chlorine shared 1, iodine shared 1. Then unshared electron on chlorine, there will be 6 unshared electron on each chlorine. Then for iodine, out of 7, it has shared 3. So how many are left? 4 are left. So for this iodine, actually a pair of unshared electrons are there, or 2 electron pairs which are not shared. So you can clearly see that it has adjusted more than 8 electrons. So elements can adjust more than 8 electrons, as above 20. It's not a fixed rule that there should be 8. It can have more than 8 electrons. Is it clear? That's why in this case, we did not consider 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 electrons are there in the outermost shell instead of having only 8. That 8 rule you will follow for first 20 elements. The next question, when chlorine is bubbled into aqueous potassium iodide solution, a redox reaction occur. Write ionic equation. State symbols are not required. So we want to write an ionic equation, only what changes in ions occur, that we have to write. So we have, first I will write a full equation and then I will write the ionic equation. We have chlorine molecule and we have aqueous potassium iodide. Because chlorine is more reactive, I'm writing the balance equation at the same time. Chlorine is more reactive, so chlorine will displace iodine. It will form aqueous potassium chloride plus iodine molecule. So because aqueous common ions, a spectator ion, we cancel out. So what we are left with, chlorine molecule react with 2 iodide ion. As a result, it will form 2 chloride ion and iodine molecule. So this is a balance equation. Then this part is related to moles concept, as we are discussing only rate, redox and reversible. This equation for a reaction of a chlorine with water is shown below. Then Cl2 plus H2O gives HCl plus HClO. This is an example of what? So if the same redox means oxidation and decomposition, it cannot be decomposition. Why? The decomposition, the condition is that we will have only one reactant. So we'll have one reactant and we'll have more product that we call as a decomposition. So it cannot be a displacement. Displacement, when the more reactive displaces a less reactive from its compound, but this is not a displacement. Why? Because if chlorine displaces this oxygen, then the other compound should not have chlorine. So that's why it is not displacement. The disproportion reaction or propionation reaction is refers to when the same element is oxidized or reduced. So how we'll identify same element oxidized or reduced? So when we write the equation, chlorine is reacting with water molecule. As a result, it will form HCl plus HClO. Now, chlorine, because it's a molecule, so oxidation number 0. As element state oxidation. Water is a compound, each oxygen is -2. We always, when we check oxidation or reduction, we check for individual atom. We don't consider the full. We consider individual, each hydrogen will be +1. That's why I'm writing +1. Total will be +2. Chlorine is -1 +1. In chlorate ClO, each oxygen is -2, so hydrogen +2, so chlorine should be +1 because the overall compound is neutral. So when we check the changes for a chlorine, chlorine was originally 0, it turned into -1. So if 0 turned into -1, this changes reduction. And the other one, chlorine is 0, it turned into +1. So if 0 turned to +1, that is oxidation. This same element, chlorine, is oxidized in one of the product and reduced in the second. That's why C is the right answer. Is it clear, this question? Then we have to work out the oxidation number. So how we can work out the oxidation number? We have HClO3 for chlorine. So chlorine is unknown, so chlorine is X. Each oxygen is -1, 3 oxygen will be -6, and hydrogen belongs to group 1 +1. And overall compound, because it's a neutral molecule, so overall oxidation number should be 0. So we can say +1 plus X minus 6 is equals to 0. So +1 minus 6, that is -5. So X minus 5 is 0. This is -5. It will move other side. So X is equals to +5. That's why C is the right answer. Then question 11. In this question, the following equilibrium was established with all the three substances present. ICl plus Cl2 gives ICl3. This is brown in color. ICl is brown in color. Chlorine is pale yellow or light yellow, and pale green, and ICl3 is yellow. What would be the effect of increasing the pressure? Increasing a pressure shift the equilibrium towards side where number of moles of gas are less. So on the reactant side we have 1 mole, but the product side we don't have any mole, 0. So when we increase the pressure, where the equilibrium will shift, it will shift towards the right hand side. As a result, as equilibrium shifted towards the right hand side, so what we'll observe or what we'll see a yellow solid will form. So no change is wrong. Increase in amount of brown liquid is wrong. That is also wrong. So we are left with only D as a right answer. Is it clear? Question 11. In question 12, this question is about catalytical converter or catalytical oxidation. Demonstrate that chromium 3 oxide to ammonia in the presence of oxygen. Some concentrated ammonia solution is allowed to vaporize in a large flask. The equation is shown here. The nitrogen atom in the ammonia is oxidized. Give an oxidation number of nitrogen in ammonia and in nitrogen monoxide. So how we can work out? So NH3, each hydrogen is +1, 3 hydrogen will be +3, and this is X. And overall molecule is 0. So X plus 3 is equals to 0, so X is equals to -3. So here it will be -3. But in NO, overall molecule is neutral, so each oxygen is -2, so this should be X. So X -2 is 0, so our X is equals to 2, so that is +2. So -3 turned into +2, it means that is oxidation. Why nitrogen monoxide is classified as a free radical? The term free radical means a substance which is having an unpaired electron or does not have a paired electron. That's why it can be referred to a free radical. So it has one unpaired electron. That's why we call that as a free radical. And when we normally draw or show symbolic representation of a free radical, we put a dot, which means that it is having unpaired electron. Then the next part, we have to draw dot and cross diagram for outer shell of NO, nitrogen monoxide. So nitrogen monoxide, there is one oxygen and we have to use dot for nitrogen and cross for oxygen. So for NO, what we can do, oxygen belongs to group 6. If oxygen belongs to group 6, it will share 2 electrons. So 1, 2. And nitrogen belongs to group 5, so it will share 3. But here, this is a NO is a free radical. So free radical means there will be one unshared electron, like not a pair. When there's not like a pair of lone pair, there is unshared electron is present. So each oxygen share 2, nitrogen will share 2 electrons. And then 4 electrons are there for oxygen, and nitrogen belongs to group 5. So 1, 2, 3, 4, and then 5. That's why you can see, because of this electron, it is known as there's a free electron available, we call that as a free radical. Is it clear? The structure of NO. Suggest suitable safety precaution. So what is the safety precaution for NO? NO or is a toxic gas, or even chromium oxide 3 oxide is also a toxic. So we should use a fume cupboard here, or wear safety goggles, or in case for chromium oxide. So these are some questions related to topic.